GCSE 9 to 1 maths, looking at types of numbers, so types of number, okay, looking at rational and irrational numbers in hopefully 58 seconds, okay, let's go. Question number 1, right, to consider the numbers below. We got pi, the square root of 144, the square root of 81, 0, the square root of -2 or -2, and the square root of 1000. Part A, write down the numbers which are rational. Now, the key with rational numbers is that, yeah, it's a whole number, or it can be expressed as a fraction, or, yeah, it gives you a terminating, yeah, decimal, okay, that's the key, okay, but some reoccurring decimals, yeah, are also fractions, yeah, so bear that in mind. So rational would be the square root of 144, because that will give you 12, and 12 can be written as 12 over 1. Okay, the square root of 81 is rational because you give you the number 9, it's a whole number. Okay, 0 is a rational number. Okay, yeah, it's just an integer whole number, and they are the three numbers here which are rational. Remember, the key for rational is that it can be expressed as a fraction, a over b or x over y, where a and b are integers. Okay, yeah, and yeah, they convert to either a terminating decimal or a reoccurring decimal. But yeah, okay, so it can be a fraction, yeah, okay, a terminating or reoccurring decimal, yeah, and also a percentage. Part B, write down the numbers which are irrational. Again, that's the opposite. So where you can't express, yeah, it as a fraction, okay, so pi, yeah, is the most common one. Okay, surds, yeah, are irrational, okay, yeah, so the square root of 1000, because that won't give you a whole number answer or an answer, and also the square root of -2, because I can't take the square root, yeah, of a negative number. Okay, again, this is obviously way beyond, yeah, GCSE maths, but yeah, this is called, yeah, this would actually give you a complex root with imaginary numbers, but again, that is way beyond, yeah, your GCSE maths exam. But yeah, if you're wondering, yeah, okay, this is what you'll start to cover in AS level further pure mathematics. Yeah, when you have the square root of a negative number. But in general, I cannot, or not general, sorry, I cannot take the square root of a negative number. However, don't get this mixed up here with minus root 2. So that will give you an answer, whereas this is not the same as the square root of -2. Okay, so bear that in mind. But yeah, any surd, so for example, yeah, root 3, yeah, it's rational, root 2, yeah, root 5, okay, you can also see, yeah, that E is rational, so E, which is Euler's number, okay, yeah, so on and so forth. Yeah, so rational means that it can be expressed as an integer and or a fraction, or a recurring decimal and or terminating decimal, whereas an irrational number cannot be expressed as a fraction, okay? And you can't get around it by writing it as that number over 1, because, yeah, that number itself is actually irrational, okay? So, yeah, so pi, yeah, the square root -2 and root 1000, yeah, are not rational, yeah, numbers. Okay, and again, don't forget, yeah, this topic here, because it's, yeah, quite a small topic here at the start of the course. But yeah, make sure, yeah, that you're happy with like types of numbers. Go over prime numbers, okay, square numbers, cube numbers, yeah. Okay, if you're doing higher tier, look at your fractional indices, yeah, obviously negative indices as well, yeah, for higher foundation, yeah, so don't neglect, yeah, the numbers topic. Remember, yeah, just as like a rule of thumb, if you have a negative power, sorry, I'm going a bit off topic here, like 4 to the power -2, that means 1 over 4 squared, or 4 to the power of 2, which is 1 over 16, okay? So negative power flips it, makes it the reciprocal, makes it 1 over. If it's a whole number, it becomes 1 over that number. And then if it's a fraction, let's say like 2/3 to the power of -3, let's say, then I would actually flip it and then cube it. So I have 3 halves all cubed, which gives you 27/8, or 27/8. okay? So don't forget, yeah, to obviously revise, yeah, negative indices, yeah, fractional indices, yeah, if it's higher tier only, yeah, your laws of indices. So when you multiply with the same base, you add the powers. When you divide with the same base, you subtract the powers. A power to a power, then you multiply any number or term to the power of 0 apart from 0 to the power of 0 is equal to 1. Yeah, and that, yeah, we have negative, yeah, and fractional indices. But again, yeah, I'll cover that more in later detail. Okay, thanks for watching.